Hi, this is Daniel Winkelman and Sammy Mwase. We did sewing and low-fidelity prototyping tools mastery.
Some of the steps we used to create our highest fidelity prototype included sewing, measuring, and cutting rods, PVC, and fabric, and the use of string to ensure that the frame is rigid. We had to use trigonometry and dimension scaling to determine precise measurements for each element of our tent.
We will show our highest fidelity prototype, but many of the principles here apply to our medium fidelity prototype as well. We had a hexagonal PVC frame held together by string running through the centers of the pipe. This was because PVC joints did not work well with the angles we needed. The string is taped to the ground, simulating stakes to create tension in the strings. At the two peaks of the tent, the frame is tied together in one set of knots.
We sawed two seams on each panel connection to create sleeves through which to slide the PVC, as shown here. This was our method of attaching the tent's fabric to the frame. Our exterior frame is supported by two inner poles that connect to the ground. Our tent also has a door and a roof held down by strings.
We encountered some obstacles which we had to overcome while creating this tent.
The sewing machine was our main obstacle. It took several hours of getting the machine to work effectively. We tried to follow the manual closely, but it took many tries to figure out. The process of repeating helped us get down the process of setting up the machine. Additionally, practicing on scrap fabric before executing our project helped our accuracy and consistency while sewing.
The other primary obstacle was figuring out an effective way of fastening our PVC frame. Since we could not use PVC fittings except for the central support, we had to devise the system of running tension string through the centers of the pipes. This required a lot of experimentation and creativity.
Even though our tent had odd angles, it had straight and flat geometry that would not have been so easy to sew if the geometry had been curved. The dimensions involved in sewing curved surfaces make it harder than flat surfaces because flat surfaces have mostly straight lines.
In our prototypes, we used a narrow zigzag stitch because it gets a lot of stitches in a short distance, making the seam more robust. This works even more effectively in thin material since it distributes pressure better.
On the whole, we were able to overcome our technical difficulties and produce a quality, low-fidelity prototype. Iteration was helpful in guiding our prototype's features. We feel like this project had given us new tools and skills for the future.